This is the last example for 10-2 quadratic functions. We're graphing another quadratic function, but in this case, it's a quadratic inequality. So we're going to follow the same steps we did in example 1, except when we go to graph it, we have to know, is it going to be a solid or a dashed line, and then where do we shade? Remember, those were the special things about graphing inequalities, was that if it's greater than or it's less than, then it was a dashed line. If it was greater than or equal to, less than or equal to, then it was a solid line. And then the shading. So if it's greater than, we shade above. If it's less than, you shade below. Same thing here. Greater than or equal to, shade above. Less than or equal to, shade below. So those are the only new things we're throwing in. Otherwise, we're following those same steps we did on example 1. So the first step, again, is to find your axis of symmetry and your vertex. So remember, your axis of symmetry is found using that equation, x equals negative b divided by 2a. So I know this is my a, b, and c. Notice that there's not a number right here in front of your x squared term, but we know there's always an imaginary 1. So if I put that there, now I know my a is a negative 1. And then I'll just plug in my numbers. Negative b to the opposite of b, so negative 6 divided by 2 times a is negative 1. So that's negative 6 divided by 2 times negative 1 is negative 2, and then we simplify positive 3. So that means our axis of symmetry is that x is positive 3. So let me go ahead and do that first. Positive 3, so x is 1, 2, 3, positive 3, it's right there. And there's our axis of symmetry. And again, we know that our parabola, when we graph it, it's going to be centralized around this axis of symmetry. Our vertex is somewhere on here, but we don't know where that is yet. So let's find our vertex now so we know where it is on that axis of symmetry. So our vertex, remember, all we have to do is take that negative b over 2a, plug it in, and that'll give us y. So that's how we're going to find our vertex. I know my x is 3. That's my x coordinate of my vertex, and so I'm going to plug that into my equation. So I have, remember when you're plugging in numbers to find coordinates, we don't worry about this inequality symbol. That's only for graphing. So I have y equals negative 1 times what was x? 3, or negative 3 squared, plus 6 times 3 minus 5. And then we follow PEMDAS. Y is 3 squared is 9, but the opposite of 9 is negative 9, plus 6 times 3 is 18 minus 5. And then again, just follow your PEMDAS. Negative 9 plus 18, that's 9 minus 5 is 4. So now I know that my vertex is, my x-coordinate was 3, and my y is 4, so my vertex is 3, 4. So over 3, here we are, 1, 2, 3, 4. There's my vertex. Now I need to find 2 other points. So your second step is, again, find 2 other points. And we know that one of them is always going to be your y-intercept. And to find that, we just need to plug in 0 for x. So I have y equals negative 0 squared plus 6 times 0 minus 5. Follow PEMDAS. 0 squared is 0. Negative 0 is just 0. 6 times 0 is 0. Minus 5, so that gives us negative 5. So my coordinate is 0, negative 5. So over 0, down 1, 2, 3, 4, 5. And then we want to find another coordinate on this same side as our y-intercept, on the same side of your axis of symmetry, so that we can, in our third step, reflect them. So you can either use x is negative, or x is 2, or x is 1. Either one of those is fine. I think I'll use x as 1 because plugging in a 1 is usually pretty easy. So I'm going to use 1 to plug in. So I have y equals negative 1 squared plus 6 times 1 minus 5. 1 squared is 1, negative 1, opposite of 1 is negative 1, plus 6 times 1 is 6 minus 5. So negative 1 plus 6 is 5 minus 5 is 0. So that means our point is, since we plugged in a 1 for x, so it's 1 for x and then 0 for y. So over 1 for x and then at 0 for y. And then remember, your final step is to reflect those 2 points. and we're just reflecting them across the axis of symmetry. So then you know your other 2 points are the same distance away from your axis of symmetry with the same y value. So it's just 2 away with the same y value. This one is 1, 2, 3 away, so 1, 2, 3 away with the same y value. And finally, you can draw your parabola. Try and hit all those points too when you do it. And make sure it looks more like a parabola than like a V. Okay, now what did I forget to do? I forgot to worry about this sign. So let me get rid of these lines, because since this is a greater than sign, we know we have to have a dashed line. Maybe that'll make it easier to draw my parabola if it's a dashed line. Actually, that looks much better. So there's my dashed line there. This side not looking so hot, but better. There's my dashed line there. Now we need to know where to shade. Greater than means shade above. Well, where is above? In this case, shading above would be above your parabola. So it's not an inside-outside thing. It's not, do I shade inside my parabola or do I shade outside my parabola? It's what's above your parabola and what's below your parabola. So if you have trouble figuring out what's above and what's below, just imagine these are slowly coming outward. They're slowly coming outward as they go down. So if you do that and you say, okay, it's coming out, then you can see more easily where above would be, and it's up there. So again, you're following the same steps we did in example 1 to find your points to graph. And you know you can always use a chart. So if you're not sure that you did this correctly, you can always go back and check by using your chart. But your first step is always find your axis of symmetry. And remember, that's also going to give you the x-coordinate of your vertex. Your vertex is on the axis of symmetry, therefore it has the same x value as your axis of symmetry does. Then use that x value, whatever you get for your axis of symmetry, to plug into your equation to find your y value. That'll give you your coordinate, or the coordinates for your vertex. Then you just need to find 2 other points so you know what your parabola looks like. And we're always going to use, one of them is always going to be your y-intercept. Just plug in 0 for x and find your y-intercept. And then find one more point on that same side so that then you can reflect those 2 points over onto the other side of your axis of symmetry.